Maybe we can start by asking you to talk a bit about yourself and about Kubesimplify, which you are both involved in. Maybe starting with you, Saiyam, as a founder, how you came to realize this idea, what's the vision behind it?
Yeah, so basically we used to host a lot of meetups. So we used to host a lot of meetups and we used to do a lot of mini conferences in Bangalore. Due to COVID, everything was shut. We weren't able to connect with people, share with people, get knowledge from the industry experts, share what we are working on. All these things were missing. So that's where this Zoom to YouTube webinar started. You can stream from Zoom direct to YouTube. So I thought, let's try it out. And it's a kind of a webinar. And slowly I realized, okay, this is a very interesting platform and we can share a lot of things in a polished version as well. And slowly we then started talking about more new technology, Kubernetes, Cloud Native, DevOps. And that's how we reached a place where my Kubernetes workshop got 1.7 million views. Then we slowly started building, and then Saloni came in and slowly started to make it a big community. And now a newsletter, 20,000 people. We have a Discord channel of 5,000 people. We have blogs. We have around 150, 170 blogs with over 700 or 800K views. So we have quite a big user base, and we do quite a lot in different areas to grow the community and make technology, especially cloud native, and now with AI, cloud native and AI integration, accessible to everyone.
Yoni, maybe can expand a bit on how does this simplify work in practice? What kind of content Saiyam contributes and what kind of content the community contributes? How would it look in practice for, let's say, a platform engineer interested in how to run LLM workloads on Kubernetes?
Yeah, sure. So previously I was with SAP and I saw a shift to cloud native technologies. Every company was moving towards cloud native technologies, towards Kubernetes. Everybody started running their workloads on Kubernetes. And then me and Saiyam sat together and I thought to move to Kubesimplify. And then we thought to make a Kubernetes course. Why not to start with the workshops? So we thought, what should we learn before Kubernetes? So we have workshops on our channel like Docker, Linux, and one of them is Kubernetes, which Saiyam mentioned. And then we also have on observability. So we started building content around the latest in tech. So we started around AI. We want to showcase, we want to teach for free from Kubesimplify. And how people contribute to Kubesimplify is there are people who creates content on our channel. Like there is one Terraform course on our channel by Kunal. And then we have workshop by Chad. It's on Docker. So people contribute in terms of creating videos. And then we have another thing like blogs.
Let's get deeper into LLMs and Kubernetes. I mean, it's clear how Kubernetes is very attractive for managing large workloads. It is maybe less obvious how it helps with managing very large bare meter GPU resources. So maybe you could start and explain what are the main advantages.
Kubernetes is one of the famous orchestrator already. So OpenAI, long back, they ran their workloads on Kubernetes and up to 7,500 nodes. This is an example that OpenAI is also using Kubernetes to run their AI workloads. And Kubernetes is also evolving. They have introduced DRA and then Multinuma. These are add-on features which we can use to run our AI workloads. As we know, for running AI workloads, CPU is not enough, right? We need GPUs for it. So Kubernetes is also evolving to run AI workloads.
When we talk about UMA, about non-uniform memory allocation, it is still CPU focused, or is it ready to also orchestrate sockets on GPUs?
Yeah, it's a bit difficult in that area. So Kubernetes has this feature called device plugins. Basically, device plugin is the concept in Kubernetes that lets you use different types of devices for your container workloads. For example, NVIDIA operator. So by default, if you just bring in a GPU, container cannot access it. You need a lot of drivers, be it NUMA. There has to be visibility to that particular container in terms of runtime class, in terms of the drivers that are installed on that particular node, in terms of how the scheduling takes place. The low-level concept is device plugins, but on a high level, people are creating abstractions, these operators that helps you do these kind of things. Like if you do NVIDIA operator, it automatically installs everything for you on a GPU and then make it available for that particular container workload. In that workload, you just put your resource limit and request. So you say, I need NVIDIA or AMD GPU that is required. So you specify that you need one GPU. and then it will schedule it on a GPU. There are already drivers, CUDA, everything installed and configured for the workloads to be consuming that. So then they hold off that. And there are a lot of problems and challenges, because if a particular thing holds one GPU and they're not using it, it's another problem. Which is why there is a thing called KI-Scheduler. KI-Scheduler was introduced by NVIDIA as an open source project in April at KubeCon, and they have actually put that as application for CNCF sandbox. Kubernetes is a beast. It works perfectly for CPU workloads, but it was never meant for the scale at which it is being used today. For scale of generative AI, it's a new hype. So architectures have to change. Similar to that, the regular scheduler is not capable enough to do the batch scheduling, to do the gang scheduling. So AI training and stuff, they require gang scheduling a lot. So, which is why you need multiple schedulers, like you need a KI-Scheduler to take care of that process. So KI-Scheduler is basically open source implementation of Run AI, the company that NVIDIA acquired some time back. So I think device plugins, DRA, like she mentioned, they are really cool concepts, and it shows how Kubernetes software itself is evolving to cater those AI platforms.
And how would you evaluate it? How much work currently systems like the way do in solving scaling up large AI workloads, and what exactly is still needed in terms of changing the architecture?
So the architecture has its own limitation. For example, you have etcd limitations, you have CNI limitations, but like she mentioned, OpenAI was able to scale to 7,500 nodes. Today, it has gone massive. Google scaled it up to 65,000 nodes. And recently, Amazon came up with 100K nodes. That's the scale that we are talking about. Forked some stuff. They have implemented their own implementation. They're not using etcd. They are using, like Google is using Spanner. So it depends on how people have plugged and play different pieces of Kubernetes to scale at where it is today. But in general, also, like GKE itself provides that you can easily go up to that 65,000 nodes benchmark, and you will be able to scale your workloads rapidly and use those GPUs effectively. But again, the challenges are GPU utilization is still low. GPU for teams is still a problem, like how you give one GPU to multiple teams. You talked about bare metal GPUs. Bare metal GPUs are also an issue, like how do you do intelligent scaling on bare metal? Carpenter is there on cloud, but Carpenter is not there on the bare metal machine. So how do you do that? I also work for vCluster. So vCluster is also open source project for multi-tenancy. So vCluster helps over there, and then KI-Scheduler helps over there, and then you have a combination of all these that makes it ready to be used by your whole ML pipeline, the training, the inferencing. And today we'll be talking more about the inferencing layer with VLLM.
Well, about VLLM, what I'm interested in is how it is integrated with the Kubernetes environment, because it is quite a traditional tool in that way. And as far as I understand, it works within each pod and one model per pod. So to what extent is this a problem that you get pretty large pods with too much resources? Does it run a bit counter to scalability?
That is true, because when you talk about these heavy images, these images are huge. We are talking about gigabyte size of Docker images or OCI compliant images. So that point is absolutely right. But all of these, the libraries, the Python libraries and stuff, they are heavy. They're heavy pieces of software out there. So you will have those, and the big size files of the Docker files will still be there, but you have to deal with that. Where VLLM helps is a specific thing called paged attention. So paged attention algorithm is something that excites the community a bit more on the inferencing side of things, how you can use that swap memory, how you can, because like you mentioned, caching is one of the issues. So one of the features of VLLM is KV caching, like how to make KV caching more possible in terms of multiple requests. When we talk about millions of requests coming in, how they can use that particular memory space to take out what is not required in the cache, put what is required in the cache based on a lot of nitty-gritties that they have put. So I think paged attention is one algorithm that they have banked on, which is good. Why VLLM actually got a lot of traction. But now there's a new project by Red Hat, which is called LLMD, which is also in the same space. It is actually, like you mentioned, like VLLM was not meant for Kubernetes. It is being used. But LLMD has been built using the same principles, but it is built for Kubernetes. And she also mentioned one thing, and even Kelsey's keynote yesterday also mentioned, the hype train creates a lot of opportunities for the existing technologies to innovate. Kubernetes was not meant for what it is being used today, which is fine. If the hype train was not there, then we would not have evolved Kubernetes to this layer. So although it's not required that everyone moves to the hype train, the hype has created a lot of new dimensions to think from the contributors, maintainers, and the open source enthusiast perspective, what we can do to enable that particular sector, that particular domain. So that is what I think is really interesting to be in this space. And I was watching Kelsey's keynote yesterday, finish the work that you started. It's a very important line. We have to finish what we started, and it takes decades to finish a tech that becomes so boring that it becomes a fundamental part of your infrastructure, like Linux.
Still a long way.
Yeah.
I mean, inference workloads also grow a lot more demanding. They are more distributed now, partly over very large distances. So to which extent is it possible to reduce the native overheads that Kubernetes provides in terms of latency especially, which is crucial for some inference workloads, and what more needs to be done?
Again, it boils down to the caching. So the more intelligent caching, the more intelligent KV caching, and the GPU utilization. When we combine these two, we get a powerful system that can scale, and then we combine the powers of Kubernetes and with the hardware as well. So NVIDIA now with their A100, and after that, they allow the GPUs to be sliced. Earlier, the prior models, you cannot slice the GPUs. So now you can slice up the GPUs so that you can have different parts of the GPUs. Although in your containerized workload, you still say, I need one GPU, and you still use one layer. But in the end, you'll not be using the entire GPU. You get hold of one particular layer. And then KI scheduler for fractional GPUs, and the VLLM for their algorithms that they have done for KV caching and memory management, or in very simple terms, intelligent memory management. That's it. So these three in combination provide you infrastructure that can scale and that can handle millions of requests, or if internally engineers are putting out inferencing endpoints. And one of the big points is that VLLM is OpenAI compatible, so you can use the same for your code completion or whatever the task that you're using it for.
Maybe to round it up, I'm thinking about the actual training side. Well, some inference workloads which are very latency critical are still pretty much run on bare metal, I think. So what's the potential to bring them closer into Kubernetes? And what's maybe the potential to bring Kubernetes more into training, especially as we are talking about distributed model training over large distance and large scales?
I think I would, since I am the cloud native person, I would say rather than bringing everything bare metal, we should bring Kubernetes to bare metal. So let's say you have a pool of nodes, in that you have some machines from NVIDIA, some CPU, some GPU machines. So what we suggest is create a big Kubernetes cluster out there, and on top of that you have projects like Kubeflow or Seldon or whatever you want to install, and then use multi-tenancy tools to create mini clusters or virtual clusters on top of that and distribute that to the teams. So that's how I would think, and I think this will be even more because everyone wants their data to be localized.
So MCP concept is also there.
Yeah.
So MCP is there. No need to give your passwords, You can just privately give your token or password and connect your cluster or your Docker machine to the LLMs or whatever you want. So MCP concept is something new which is trending right now.
Everyone is thinking about privacy. Everyone do not want to give the data to the open LLMs out there. So people want to use the open source models which are hosted in their data center on their bare metal machines. We are seeing this use case a lot, and I think this is the future, everyone having mini data centers specifically for their AI workloads.